Welcome to Mrs. Riley's Maths videos. This is a video in probability, and it's a very quick video covering an idea called at least one, which is a useful concept when we are working through probability questions that are a bit more complex. In this question, or in this situation, what we're being asked is, what's the probability that something happened at least once? So that could be that it happened once, that it happened twice, that it happened 3 times, or whatever, depending on the situation. So if there's a way of finding out this without having to list all the outcomes, that can help. Here's an example we'll look at first of all. A coin is tossed twice. What's the probability that there is at least one tail? Now, to help us to visualize what's happening, I'm going to list all the possibilities for a coin being tossed twice. So on the first toss, it could be a head, or it could be a tail, and on the second toss it could be a head, or it could be a tail. So my 4 possibilities are that it's a head, 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 tail, tail, head, or tail, tail. As you know, that's a tree diagram, and this is called the sample space. Now let's work out first of all, what's the probability that there's at least one tail? So there's at least one tail here, there's at least one tail here. Sorry, there's 2 tails here, there's 1 tail here, there's 1 tail here, there's no tails here. So in these 3, there's at least one tail. There's 1 tail, or there's 2 tails. So in these 3, there's at least one tail. So the probability of at least one tail is 1, 2, 3 out of 1, 2, 3, 4. Notice please that covered the probability of 1 tail or 2 tails. Okay. However, there is an easier way to do it, or there's not a trick, but there's a way to see it that helps us without having to list all the sample space, because listing the sample space can take a little bit of time. The probability that there's at least one tail, as we said, is 3 out of 4. The probability that there's no tail, there's only one of those, which is 1 out of 4. If you notice, when I add those 2 probabilities together, I get 4 out of 4, which is 1, which is the complete sample space for any event. When I add them all up, is 1. So the sum of all the probabilities in the sample space totals, well, I've said sum is 1. So from this we can get this idea that the probability that there's at least one is going to be 1, the total number for all the probabilities, minus the probability that there's none. Okay, the probability that there's at least one tail is 1, so the probability at least one tail is 1 minus the probability that there's no tails. And no tails was 1/4, so 1 minus 1/4, which is 3/4. Let's take another example and see whether it makes sense. 3 friends agree to meet up for a meal. Chloe has a 90% chance of being on time, Siobhan has an 80% chance of being on time, and Charisma has a 70% chance of being on time. What's the probability that at least one will be late? Okay, at least one will be late. So let's think that through. The probability that at least one will be late, so at least one will be late, is going to be 1 minus the probability that they're all on time, which is the same as saying 1 minus the probability that none are late. Do you see that? 2 different ways of looking at that question. The probability that at least one late will be 1 minus the probability that all are on time, or 1 minus the probability that none are late. So the probability of them all being on time, well, Chloe has a chance of being, so the probability that all are on time means that Chloe is on time, and Siobhan and Charisma are all on time. So what's that? That's 90% times 80% times 70%. Why am I multiplying? Because of this and. Chloe's on time, and Siobhan's on time, and Charisma's on time. So the probability that they're all on time is going to be 90 by 80 by 70, 90 by 80 by 70, which is 504,000 over 100 times 100 times 100, which is 1 million. So if I write out what that is, 504,000 divided by 1 million, I get 0.504. Okay, or what was that as a fraction? 63 out of 125. So that would be what, 50.4%. The probability that at least one will be late, that probability that all will be on time is 50.4%. So this is the probability that all are on time. The probability then that at least one will be late is 1 minus that. 1 minus 50.4%, which is 49.6%. So there's a 49.6% chance that at least one of the people coming to this meal will be late. I hope that helps.